All right, class, welcome back to another day of science class. We just completed our activity with speed, and now we're going to do an activity talking about speed and collision. Okay, so we're talking about how does the speed affect the collision or the result of a collision. Today we're going to learn a new word. The new word we're going to learn is called force. May the force be with you. Okay, you know that right? Okay, so what is a force? A force is simply a push or a pull. A push or a pull. Okay, come on, James. Come on, you know how to do this. I'm stronger than you. Okay, you're supposed to go that way, right? Tug of war, a push or a pull, okay? All right, you can let go now. Okay, so we're talking about push or pull. In science, you cannot see a force. A force is not visible. You see the effect of a force because of the change in motion. The change in motion can be bending. It could be, speeding up, slowing down. It could be accelerating, which is speeding or slowing down, or changing direction. So once again, you cannot see a force, but you see the results of a force, okay? The effects of a force. So what we're gonna do today, class, we're gonna do a quick activity. It's not gonna take us very long at all. And James, of course, our helper. Say hi to James again. All right. And we have a new recorder today. My son, DJ, decided to opt out today, and I have my daughter here again today. Okay, so what we're gonna do, James is going to set up the ramp as shown. We used it when we ramped in our last activity. But here we have a block, and then here we have our cart. So he's going to release the cart from the highest height. Now remember, in our last activity, you should learn that the speed was higher or was greater when we released it from A as opposed to releasing it from C, right? It was higher at A than it was at C, okay? So we're going to release the cart again A. So I'm going to read it, and then I want you to follow along, and you're going to fill out your dad table. Jimmy, show them dad table here, please. So dad table here, you're going to fill out, okay? All right, so here is the experiment. It says set up the ramp and track as you did in activity 74, measuring speed. Mark the track 5 centimeters from the bottom edge of the ramp, we did it already, and place the block there. So we already placed the block where it's going to be. Hold the cart, ready, James? Hold the cart so there's axles at notch A in the ramp. As you learn activity 74, release the cart from notch A results in the fastest car speed. Release the cart and observe what happens. So he's going to release the cart, class. Okay, now don't do anything yet. We're going to measure the distance that the block moved down the track. So we're going to measure distance, James. So can you tell me what is that distance? Look here on the meter stick. Look at the meter stick. What's my distance?
26 and a half.
26? Wait, oh no, you can look at the front.
21, 22.
Is it 22 exactly? We got to be exact in science class.
21.8.
21.8. Good. So Jameen's gonna write down 21.8, and for trial 1, 21.8. Okay, good. James, you're gonna do it again. You ready? All right, good. Do it again, James, and do it 5 times. Go ahead, James. 5 times from A, then we're gonna do from B to C. What's that?
21.3.
21.3. Okay, write that down. Can you make sure you show that to? No, that's the wrong spot, Jamie. We're doing trial B. Trial 2. I'm scared. Sorry, trial 2. 21.3. And show them that. Okay, good. Do it again, James. All right. What was that?
21.3.
All right, do it again.
.6.
20.6. 20.6. Is that 20.6 to me? Make that 0 a little better. That looks like a. Just add to it, Jamia. Okay, do it again, James.
20.5.
20.5. You show that too here too, Jamia? So they know it right here too, baby girl. You did? Okay, good. Good. Now, class, I forgot to ask you to make a prediction. Well, actually, it says do it now, so I actually didn't do it wrong. Okay, who can tell me if we release it from not to be? James, can you show them not to be? What do you think will happen to our collision? What's going to happen to the block? So what we have to do now, we have to come back here and we have to figure out if we are releasing it from different heights, which collision is going to be the worst. So which one is going to cause the block to move the furthest? So our question is going to be, which notch is going to cause the block to move the furthest? That's going to be a problem statement. Which notch is going to cause the block to move the furthest? So you need to do your hypothesis. I'll give you a second to do that because we didn't do a hypothesis yet. So which one? Is it going to be notch, right here, Jimmy, so that's one. Notch A, notch B, or notch C? Which notch is going to make the block move furthest? Okay? All right, hopefully you did that already. Now let's go to the next one. So we're going to do the exact same thing, class. This time we're going to release it from B. What's that, James?
13 point.
Not 13. It's not 13.
12.5.
12.5. Good. He's reading upside down, class, so it's a little harder. Okay, try it again, James.
$11.6.
Good. We're going fast now. We're getting the hang of it.
12.6.
12.6?
12.1.
12.1. Good. That's why you have a partner to help you out. I'm your partner.
11.3.
11.3. Good. Do it again, James. Got one more for this trial, then we go to C.
$11.9.
11.9. Okay, good. All right, can you do C now, James? And Jimmy, are you letting him see that?
Yes. 7.
Okay. Yeah, that's perfect. I think that's 7. I'll agree with that one.
$6.8.
I agree with that. You can show that. You can show it over here. Oh, I think he went from wrong with the wrong one that time.
P.
He went from B that time, so you have to go back to C. That trial didn't work.
6.9.
6.9. Okay, two more. Two more, class, and then you'll be able to figure out your own averages. It's like we're back in math class.
7.
I agree with that. One more.
.9.
Okay, class. So now, okay, so think about our first activity we did when we calculated speed using, what's the timer? Using the timer and the distance. Okay, this time we didn't use the timer. Okay, we didn't do timer this time. We were trying to figure out if the speed affected collision. First time was trying, in first lab was trying to figure out how to calculate speed. This time, whether or not the speed affected the collision. And hopefully that was clear. Now, before we go on, class, I do want to show this to you. You have this in your activity, but I want to go over this real fast, okay? So here, I drew some pictures to help us understand what was happening here. So if you look here, we have the cart, and you saw the green cart, and we have the ramp, and you saw the brown ramp, and you have the track here, okay? So the force of the cart on the block. What happened? Can you show this part to Jamia? What happened when the cart hit the block? The block did something, right? The block, it did what? It sped up. So the block sped up, right? You saw it speed up. And what happened to the cart when the force of the block on the cart? The cart did what? The cart slowed down, right? Can you see me? The cart slowed down. Okay, let's go back here. So the cart slows down because of the force of the block on the cart. The block speeds up because of the force of the cart on the block. Okay, this is one way to write this. Okay, this is another way to write the same thing. Okay, the exact same thing, but it's written a little differently. This time we don't have the ramp in it, and we just have a box here. This showing here that this block is exerting a force on this cart, force of block on the cart, which slows the cart down. This cart is exerting a force on the block, which speeds the block up. I think that was pretty clear. And then we have the last one. This is the way you're going to see it. You're not going to see it the first two. You're not going to see like this. Not see like this. Okay. You might see when I'm teaching it, but you won't see this for a problem. This is how you're going to see it for a problem. Okay. And this right here. Okay. So the cart and the block, and this arrow right here is this arrow here. Can you see that? This arrow and these two arrows are the same. All right. So this is showing the force of the block on the cart. All right. And this arrow is showing is this arrow. See that? Can you show both arrows at the same time or not? This is showing the force of the cart on the block, and the block speeds up. Now, we're going to have some problems like this in the future, so I want you to study these three diagrams and understand them. Okay, let's say thank you to our helpers today. We finished that lab. We went fast. I know we did, because I want you to have plenty of time to do the assignment in class. So this one should not have been a hard assignment. Hopefully you saw that the speed obviously affected the collision. All right, let's say thank you to our helper. See our helper, James. Say hi, James.
Hi.
Or I said bye now, huh? Bye. And then my daughter, Jamia. There's Jamia.
Hi.
And okay, class. I'll see you in class. Bye-bye.